This video is the second video in a series that provides an overview of the cable analysis functionality in Softtree's terrain. Now in the first video we focused on just using the tool to analyze deflection along existing roads. In this video we're going to focus on using the tool to locate desirable locations for new landings. Now with this, I'm going to just start out by picking up where we left off in the last video. So here I've got one landing location proposed up here. I've got another landing location proposed down here. Two others. But I can see it's going to be very difficult to access this portion of the block. Now for this, just to do a little housekeeping and tidy things up, I would like to just remove some of this line work so it's a little less busy. So I'm going to right click, select features by name. We're going to go down here and we're going to select all of our, well actually we'll do it tabularly. So we're going to go with all of our D-line explore features and I'm just going to delete them. So I'm going to highlight all of these, I'm going to click select, they're highlighted, I'll click delete, but I'm keeping my boundaries just to make it a little easier to see what I'm dealing with. And so here I'm just going to hatch these, and I'll hatch them in red. So I'm going to go back to my cable analysis tab, and I'm going to look for where I may want to put a landing here. Now just looking at kind of the topography in general, this top of our ridge looks like an obvious spot, but it might not give us a lot of advantages of setting up there. So if I click that and I set my max logging distance back to that and use the LC650, which I'm using elsewhere, we can click around and we see we're not able to really get over the break. Now if we go down to this next ridge, we're doing better. If we'd like to check our analysis, and here I'm just going to kind of reduce what we're working with. It looks like this portion is going to be the hard part. So we'll hit OK, and again we'll click that feature and we can see we're going out there. But if we walk this back so we're not going too far out, how is that going to work for us? Let's go to 110, and we can see we're running a fair bit of ground lead. Similarly here, we could check that out, and here we're going to have deflection issues too. Oops. I'm just going to click zoom to extents so we can see that. So again, we've got deflection issues, and if we push this out further, say maybe to 160, it's going to be even harder to get the lift that we'd like. Now, I'd mentioned in the first video that the tool can be useful for other things. So I guess we'll put those back there. Rather than just looking at how far we can get with it, we're going to use another one of our options. So I want to go out to, say, station 160. We have that issue with ground lead. We can change our calculation method, and say, well, what if we want to keep that grapple 2 meters above the ground? So this option, the maximum flying load given clearance, I'll increase the number of slices so it tracks well. It's not a very interesting graphic here. All it is the carriage path line is offset 2 meters from the ground. What is more interesting is if we would like, we can click our 3D options, we can add in a subview, and we can see we've added in our load, and we can see as we go further along this, we are able to yard a smaller and smaller piece size until we get to, well, out here where we are in the vicinity of 2000 kgs, and then, well, the geometry just doesn't work. We can't stay above that 2 meter offset. Again, we could play with our settings, crank that up, and we see that, well, even if we do that, we really run into issues maintaining that max height at that point. So I don't like this location. It's not going to give me a large enough piece size. Let's look at another location. Use this again. Allow it going in all directions. And, well, if we go, say, there, we can hit OK. We can see what we're working with. We can run that out to, say, just 80. We're running ground lead, but we're using that same height. We can bump that up just a little bit, and we're in business. So I like this landing location. Now the only problem that we're dealing with now is that landing location doesn't have road access. So here we're going to use another tool in the toolbox, and that's Path Explorer. So we're going to plan our road to get a landing into that location. So with this, Path Explorer considers earthworks costs, but we'll also probably want to consider our crossing costs in this. So we'll use our streams and ponds to generate the flow vectors. Then we'll go to Home, we'll create a new feature. So this is the feature that we'll use for our deflection analysis. So I want to get my road to that location. I want to keep my grades less than 18%. I'd like to have my curvature stay above 20 meters. I'll look for 5 options, and I'm going to say that those streams cost a little bit more than just my default costs. So here I'm going to select my streams features. Rather than doing it manually, I can go to advanced. I can select them that way. I'll say each one of those streams costs typically $2,500. We'll hit OK. We'll hit OK. It's searching for 5 possible routes to get from that point there to that desired landing location. It says unlikely to improve. We'll hit cancel. We'll hit OK. So there we can see our possible routes to get from that existing road out to there that have considered our design constraints. Now if we'd like to weigh which one of these is the cheapest, we can go select by name, and we see the XPath features with a number after them. So 95K is our cheapest in this case, so it looks like that's our cheapest route to get there. Here I'm going to save my terrain file. And I'm going to switch over to location to take that line on the map and turn it into a proper design. So we'll minimize this, we'll open location, we'll click new. I'm going to grab that terrain file that I've just saved. My initial alignment, I'd like it to use that XPath feature that we've just created. And I'll click zoom to extents on my 3D so I can see what we're dealing with. Now to start, I would like to turn this polyline into a proper series of curves and tangents. So I'll go to there. I'll set that to be that. And I'm going to run my vertical optimization. So here I'll put in my minimum and maximum grades, my minimum maximum K values. I'll click add edit. If I have any control points in terms of elevation, I'll add those in. I'll click process and I'll click run. And there we are. We have our balanced cuts and fills. We've got an alignment that adheres to our design constraints. We've got the road going to our proposed landing location. And if we'd like, we can even add in our culverts. Once we're happy with that, we may want to look at our volumes so we can see how much cut and fill we're dealing with. And we can produce our documentation as we wish. So here I'm just going to use a pre-formatted package that I have set up with my plan over profile and my sections all automatically combined for me. If I wish to take this design out for construction staking or share with colleagues in another software, we can hit File, Save As, and change our extension to a number of common formats, including land XML, shapefile, DWG, etc. Thanks.